Alright, so this is a demonstration of my BoggleSolver and Sudoku solver. The description is kind of hard. It's hard to describe what this thing does, but I can show you a lot easier. So I'm going to go ahead and start this program that I've written. It'll take a minute. It has to start a few threads, and right now it's using GPU acceleration. So if I take this Boggle board, right, mix it up. Everything gets in there. Let's fix one or two of these guys here. And then I take this, line it up. Then you can see over here, you get output of all of the different words that it was able to find. And here, you can click on it and find the definition. So that is the BoggleSolver portion, and I will go over how it works after I show you the Sudoku solver portion. Alright, so this is the Sudoku solver portion of the project. I had to stop the recording because I actually have a different version that I wrote that works with both Boggle solving and Sudoku, but the Boggle solver is a lot slower in this version, so I separated the two programs. But I'll go ahead and run this. I'll go ahead and choose 1 for Sudoku solver. Go ahead and select it. Here I am again. So I can go ahead and take this. The Sudoku solver is a little bit more finicky because there's a lot more that it has to find. But if I line this up, give it a sec. Then it's able to find all of the numbers and figures out where they're supposed to go. So that is the Boggle solver. No, the Sudoku solver, sorry. So I'll go ahead and get into some of the technical details for those of you that want to continue watching. So now we're getting into the description of the program. If you're not familiar with the terminology here, I would recommend looking it up because it's really interesting and I thoroughly enjoy this stuff. And I think many people would if they understand it. So basically what I'm going to do is I'm going to go over the way that the information passes between processes and threads and what they do. So I start off and I create an attempt Sudoku or attempt Boggle solve, which is kind of after a lot of filtering has been done to the images. They get taken off of queues in multiprocessing and put onto here to where it attempts to solve either Sudoku or Boggle. And it'll just do this over and over and over again until it finds something. Here, this is the display and the show final image, which is a thread that will actually put the information together and give you a display of the final image. So here I'm just cleaning up the image. Basically, when it comes to image processing, you want to filter out as much data that you don't want as possible. And because I'm using things that are usually black and white, I don't need color. In fact, later on I'm going to use what's called a threshold, where it turns anything that's 50% or greater black, it turns it all the way black, or 50% or greater white, all the way white. But before that, basically everything gets put onto queues, and it also shows you the image, so that way you can see and align the board with where it needs to go. Then you can go into the, let's see, it is the thread worker. And this is where a lot of those functions that I was talking about earlier that are in different processes are stored. So the show final image, it's basically seeing if is there something in the queue. If the queue is empty, just keep looping until you find something. And it's very similar here, except here it actually attempts to do some of the solving in it. So I'll go ahead and go over kind of how everything works. This is the Sudoku model. So I trained this using sklearn library. So with it trained, it's basically just a neural network that's looking through the cleaned up image and loading from there. But this just gets loaded up when it starts the process. And this is kind of a rudimentary way of creating a, I guess, a look back system to look at multiple frames at a time to check their values to see if something was recognized in the frame before, but it's not recognized now because most people aren't going to be moving the board around super fast, and it'll just help with accuracy. So here, because we were putting everything on the queues in this, it's just looping over and over again, putting stuff on the queues, starts pulling stuff off the queue, and it goes into this function right here where it does quite a few things. So if I follow it, here I'm just saying how many, what I guess 9 by 9, and here's 4 by 4 for the boggle. And then both of these do the same thing. So I'll go ahead and go to the parse grid. Here we pre-process it, which is dilation, adaptive threshold, bitwise. Basically, this takes it, blurs it. It takes the black and white, blurs it, and then does that adaptive thresholding where it splits it all or nothing. And then it returns the processed image. So let me go ahead and get back to it. Then it resizes the image to a standard size. And that way the neural network you can specify different sizes, but the neural network will always look for something that's 500 by 500 in this case because that's what it's trained on. So here this uses a technique that it's called find contours, and it uses math to find lines and curves in images. And once it finds them, I try to find the largest polygon, which is the most likely the outside of either the boggle board or the Sudoku board. And then I will set that as coordinates and pass those coordinates out. With that, those coordinates get passed back out, and then they are cropped and warped to that. So say it's turned sideways and it finds it, technically it'll still be able to process that image. It doesn't have to be lined up perfectly with the square. So it can find the image that it needs and rotate it, and turn it square if it's a little bit tilted or something like that, so that way you can actually use it. Then right here, it takes the image, splits it into, depending on what you're using, 81 or 16 squares that are cropped, so it removes the lines in between. So the, I guess, plastic in between for the boggle board and the lines that give you the structure for the Sudoku board. And then it passes all those as a tuple or a list back, and then that gets put into here where it puts them all together and you're able to see it, and it also passes it back. for the parsing. And then it goes back to the final image, and we are back out to here. So quite a bit of stuff there. Does a lot. Here, it's that error correction again. It's just a way of making it so it can look back a few frames and see if it can find anything. Then it puts the image back onto the process digits where it runs an AI. It runs on a trained AI that I made. Tries to figure out what the answer is, and then here, because this is Sudoku, it's checking for if a value is a blob that it can't recognize or if it's a blank space. And it's just running some error correction by looking back a few frames and just double checking. So there's all that. This is just initializing some stuff, getting stuff set up. This is just, once again, some error detection. And then here is where the, I guess, solving happens. So with the AI, we've received a bunch of digits in a list, and it goes through and tries to solve the Sudoku. And I don't want to allow brute force because sometimes the system doesn't pick up certain values and it'll just try to do it on a blank board. So it'll just brute force and just take up all the time. So I wanted something that could be done algorithmically. But the brute force, it tries it. If it takes too long, then it just skips it and says to stop. But then once it's finished, it puts all the numbers on the image and puts it on that thread or into that queue where that thread is looking for the final image, and that thread shows it. Now for the BoggleSolve, it's very, very similar. The only difference is I used a TensorFlow library, and I wrote the TensorFlow model myself using Keras, and it's pretty basic, but it works really well just because the squares are very, very small. They're not a ton of pixels. And I just run it on GPU. I have a batch size of 50 with 200 epochs. I train it, and if my accuracy is below 99.9%, then it redoes it, or I will redo it. It doesn't do that automatically. But yeah, so that's how that all works, and it's very similar for the Boggle. It just uses a dictionary and uses depth first. No, it uses a breadth first search, and it's able to find all of the different letters and everything. So that is this project. The code is a little hairy, but it is functional, and I do plan on eventually cleaning it up and putting it into some sort of an Android or iOS app.